Hello students, very exciting day today. We're starting to look at our planets. Okay, so today we're going to start with the inner planets or the terrestrial planets. Okay, so these are the planets. I expect you to know all the planets in order. So Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune. If you want to put Pluto on there, I'm okay with that. But remember, we can use the memory device, the mnemonic called the "My very educated mother just served us nachos," or in the old days, "My very educated mother just served us 9 pizzas." All right, so I will expect that. Remember, you're going to have a quiz at some point, which, by the way, I'm going to try to get that onto Google Classroom so you can just take it multiple choice on Google Classroom. Okay, so let's try that. Hopefully, y'all all can find that. All right, so today we're going to be looking at the terrestrial planets. Remember, we talked about how there is the asteroid belt right in here between Mars and Jupiter, and how Jupiter's really, this is not to scale at all. Jupiter's way far out. So we're going to be looking at these inner 4 planets today, the terrestrial planets. On page 179 of your student activity guide, you're going to find charts, okay, 179, 180, and you're going to be filling in some different data on those charts as we go. All right, this would have been one of the things I would have graded on your lab pages, to see that you're filling those in. All right, so just have that open in front of you, and you're going to see some different types of data. So let's start with Mercury. It is the closest planet to the sun. If you know who Mercury is in the pantheon of Greek gods, Mercury, I guess he's Roman, right? That's the Roman god. Hermes in Greek was really fast. He's the god that has the little wings on his sandals, right? Because he's the messenger. So he goes really fast. So this planet's named Mercury because it goes really fast around the sun, okay? Because it's got a very short year because it's very close to the sun. All right, so its closest, it's about 1/3 the size of the Earth. It has no atmosphere, so the temperature is swinging wildly from day to night. So it's 800 degrees in the daytime when it's facing the sun. And at nighttime, it is -300 degrees. So it's not very hospitable there. Okay, 1 year is 88 days. In other words, it takes 88 days to go all the way around the sun. It takes us, 365 days. It takes it only 88 days to go around. Now remember, when it's turning on its axis, right, we're going to call that rotation. How long does it take it to turn? It takes 59 days to just turn once. It takes us 24 hours to turn once. So you can see why that daytime temperature gets so hot, because the daytime lasts a long time. And therefore, it's got a long time to heat up by hitting the sun. And nighttime lasts a long time. Therefore, it's cooling down to -300. Wow. Okay, so we know very little about Mercury because it's kind of hard to study since it's so close to the sun. Every time we train any kind of telescopes on it or wherever, the sun is so bright, we just see a little dot, on the sun, and it's Mercury right there. So we have sent a couple of probes out to take a look at it. The Messenger probe, for instance, was sent in 2008, and we saw this picture of the surface of Mercury. Because of the size of Mercury, about the size of our moon, it's got less gravity. So if you can do a 10-foot dunk here, like a basketball, you could do a 26-foot dunk on Mercury. How fun would that be? All right, so there's some other, it does say it has a thin atmosphere. I don't know that it doesn't have enough gravity to hold an atmosphere. Okay, so if it is, it's very thin. Since it's very thin, I don't know that it's there at all. We have lots of craters on it, similar to our moon having lots of craters, because there's nothing to stop the space dust and the other debris coming in and hitting the surface. We did our craters, remember our crater creations, we did those, and how big craters make big meteoroids make big craters, and etc. So here it is. This is what we see often. It looks like that. The sun is right there, and it's very hard to see it. We have seen this. So that is a photo of it right there, and you see lots of craters going on right there. So Mercury would not be a place where people could live. I don't even know that we want to travel there, and the reason is that it's so close to the sun, right? Which side would we land on? The really, really hot side or the really, really cold side? So here are our stats. This is the kind of things you're going to be filling into your page on your book page, right? So right here, it's the planet closest to the sun, Rotation, 59 days. That's rotation. That's 1 day. Revolution, that's 1 year, 88 days. All right. Right here it says it's the second smallest planet in size. That must have been old fact. That must have been when Pluto was still a planet. So right now I believe it is our smallest planet in size. Okay, it's close to the sun. It has weak gravitational field. It doesn't hold an atmosphere. It has the shortest year in the solar system, which makes sense. Okay, moving on to Venus. Now, Venus was named after the goddess of love, the Roman goddess of love, also known as Aphrodite by the Greeks. And the reason they did it is when you can look up and see it, it looks beautiful. It's this beautiful yellow, glowing. Well, boy howdy, it's not beautiful once we found out what was going on up there in Venus. It is known as the morning star. It's sometimes actually also called the evening star. So typically, if you look up at the sky at night and you see a single star in the sky, and you say, "Starlight, star bright, the first star I see tonight. I wish I may, I wish I might have the wish I wish tonight," right? That's usually Venus that you're seeing right there. So where Mercury had no atmosphere, Venus has a very, very thick atmosphere. And so it has a constant temperature of 872 degrees Fahrenheit. Yikes. It's beautiful at a distance, but up close, not so much. 96% carbon dioxide atmosphere with clouds of sulfuric acid obscuring the view from Earth. There's no magnetic field. That's interesting. And it rotates retrograde. That means it's going the opposite direction of all the other planets. So that's kind of interesting that happened. So we see it here. It's often visible. Sometimes they call it Earth's twin. It's about the same size, slightly smaller than the Earth right there. And therefore it has the same amount of gravity. So if you can do a 10-foot dunk here, you can do an 11-foot dunk there. Here's that atmosphere right here with carbon dioxide and nitrogen gases right there. Y'all check me on that sulfuric acid one right there. This is an interesting picture right here. I think I'm going to show that to you here in another slide. It took us a while to figure out what the surface of Venus looked like because we could never see through the clouds. So we would send probes over there and we would see all these clouds swirling around, and we never knew what was going on underneath there, what was happening underneath there. I'm going to go to our next slide, but real quick I want to say, look at this right here. They're talking about the metal core and what the inside looks like. Okay, we have no idea, y'all, what it looks like on the inside. We live on the Earth and we don't even know what our core looks like. So for them to make this kind of guess, it's in my mind is irresponsible. We don't. The only thing that lends toward any of that is the fact that it doesn't have a field, a magnetic field around it. So that's the only thing that kind of lends toward that. Let's see if I have that picture. Okay, it's also hard to study from the Earth. There was a probe that landed on the surface, took 2 pictures before it was crushed by the overwhelming atmospheric pressure. All right, so all those thick clouds and all that kind of stuff, they impose a massive amount of pressure upon anything. And so even these Russians actually sent the probes up there. And the first one they sent was completely crushed and got no data. They sent up several more that didn't have any cameras but had other types of data collecting devices on them, and they sent some things back that gave them the idea, oh my goodness, if we want to take pictures of this place, we're going to have a really beefed up probe to go there. And they had this thick titanium probe with the little camera that kind of, once it landed, came out and took those 2 pictures and then crushed. Here they are. There's one of the pictures. This is the foot of the probe right here. Okay, part of it fell off when it hit because it hit so hard. And this is what we've seen. All right, and then later they sent another probe up there with a little more, protection around it, and were able to get a picture that wasn't just of the surface. This camera was supposed to take a picture of like the horizon, right, of what it looks like if you're taking a picture of the land, but it ended up having so much damage from hitting so hard that the camera just smacked downward, and all we got was this picture right here of the surface. So the other one kind of shows these sort of mountainous regions, kind of things like that. So here is on our stats right here. It's known as the morning star and the evening star. It has a rotation of 243 days to go 1 day, y'all. And its revolution is 224 days. So that means its rotation, its day is longer than its year. So going around the sun, it only takes 224.7 days, but just turning on its axis backwards, it takes 243 days. Wow. And remember, it had that constant temperature. All right, the brightest object in the morning and the evening sky. It's the closest planet to Earth, covered with thick clouds, and it has that retrograde or backward rotation. All right, that's Venus. Now we're gonna skip Earth for a minute and come back to it at the end. We know the most about Earth, obviously, because we live on it. All right, Mars is our next planet out, the last of the terrestrial planets. And it's called Mars after the Roman god of war. And it's called that because it was red. And red like blood, you know, we're going to have, you know, warfare and this kind of thing. All right, so Mars is interesting. We're going to talk about, we're going to talk about its comparison to Earth right here, but about possibly it taking a trip to Mars, right? It has many similarities with Earth. One of the things it has is a tilt like Earth has, so therefore it has seasons, which is unusual, right? It's spinning in the same way. It is much smaller than the Earth. It does have a thin atmosphere, which makes us very hopeful that we could beef that up a little bit and actually what they call terraform it. If we terraform it, that we could create a planet there. We could go live there, right? All right, the days are about the same length, about 24 hours. We'll get to that stat here in a minute. But the year is double, obviously, because it's farther away. There's a possibility there may be water, but there's no evidence of life. We have sent several probes to Mars. It's been one of the easier ones to study, although it's easier to get a probe to Venus because of its proximity, and the way going in that was just easier for us for NASA. But to go out to Mars is a little more difficult, but we can actually see stuff, right? We landed probes have collected and done little tests and this kind of thing. So the atmosphere is mostly CO2, so think about that. There's negligible oxygen. So, but think about it. If I took plants up there, plants need CO2, and what do they make? They make oxygen. So the thinking is, if we could get plants up there, they would have plenty of what they needed, which is the CO2. They'll need water too. We'd have to get water to them. And of course they need sunlight. Yeah, so the sun is not as close at Mars. It's not going to have days like we have here. It'll be cooler there. We don't know about there being any liquid water there at all. There may be frozen water. We're not 100% sure that it's water. It might be frozen ammonia. The daytime temperature is 65 degrees. Nighttime, yikes, negative 220? Is that right? It does have 2 moons. Interestingly, I think that video we watched last week, or the week before last, I think it was, it kind of suggested that maybe those moons came from the asteroid belt. I thought that was an interesting idea. Those were they were in the asteroid belt, but Mars had enough gravity to capture those and put them into orbit around it. That's pretty cool. All right, so we know that Mars is red, and we think what's happening is the little bit of oxygen that is in the atmosphere is actually oxidizing metals that are found in the dirt. So we think there's probably iron in the dirt there that's being oxidized. We're not 100% sure about that. It does have that thin atmosphere. It's smaller, so therefore, look, I could dunk a 26.3 foot basketball situation going on there because it's so much smaller. Here you can see a Martian sunset. This was a rover that took this picture. That's how the sun looks. I cannot imagine a daytime temp of 5 degrees. That's okay, right? Boy, howdy, we'd have to have some heaters for us there. Once again, the conjecture here, silly. Okay, we have no idea what's inside there. These are the moons, Phobos and Deimos, all right, which I believe were twins, right? And notice they're not very round, but they are orbiting, so they are considered satellites of Mars. Here is one of the probes we sent down there. Okay, it was very cool. We landed it. We had parachutes and all this crazy stuff to land there. And here's some of the pictures that were taken on the surface right there. Very rocky, very dry. This picture was taken, which got a lot of people thinking, oh my goodness, somebody built that. That can't be coincidental. Somebody built this, alien head. Well, it turns out it's just a mountain type thing, and it just had that appearance with the light shining on it. It looks like a face. It's not really a face. Okay. We have named a lot of stuff up here. It turns out Olympus Mons is a massive volcanic mountain that's bigger than any mountain or volcano on our Earth, bigger than Mauna Kea even. Okay, so it's huge. And then we have all these different, these different names that we've given all these areas here. Here's our stats right here. It's called the Red Planet. It has a day of 24.5 hours. That's real close to Earth, right? But it takes, look at its year, 687 days to go around the sun. All right. It's the fourth planet from the sun. We believe there's iron oxide in the soil, which is why it turned red with the oxygen. It's most like the Earth, but it's very dry. It does have seasons because of its tilt right there. Okay, so when we say it's most like the Earth, the idea is that it would be able to keep liquid water on it with those temperatures, apparently, is what they're thinking right there. But like I said, we don't know that there is any water there. Let's watch this interesting video that's going to see about maybe traveling to Mars. Y'all have heard a lot about that. Y'all might be the first group of people that actually is realistically looking at traveling to Mars. Let's see.
We could have been on Mars 30 years ago. At the peak of the Apollo era in the early 70s, NASA was already planning its next step into the unknown. Its plans included building multiple space stations, continued trips to the moon, and its first crewed mission to Mars by the 1980s. Can you imagine watching astronauts walk on Mars the same time the Walkman came out? But of course, NASA never sent humans to Mars in the 80s. And here we are, 30 years later, still dreaming of the possibility. But the reason isn't necessarily a matter of technology or innovation. It actually comes down to politics. As a government agency, NASA's goals are determined by the executive branch. Since its inception, NASA has served under 12 presidents, and it was clear near the start that not every president would support NASA equally. By the end of the Nixon administration in 1974, NASA's budget had plummeted from 4% of the federal budget to less than 1%. Fully funded Apollo missions 18 and 19 were abandoned, along with Apollo 20. At the same time, Nixon pulled NASA's focus away from the Moon and Mars and instead towards low Earth orbit. His parting gift was to sign into effect what would eventually become NASA's Space Shuttle program. But this was just the beginning.
So what's happened throughout all of space history after the Apollo program was over was we had this start, stop, cancel. So a president comes in, like President Bush comes in and says we're going to go to the moon, back to Mars, and then the next president comes in and cancels that. And the next president sets their objective, and the next president comes in and cancels that. The agency's unable to sustain consistent funding long enough to do anything.
It wasn't until the Space Shuttle program was nearing its end that a crewed mission to Mars was finally considered and funded by a U.S. president. George W. Bush, in 2004, announced,
"We will give NASA a new focus and vision for future exploration. We will build new ships to carry man forward into the universe, to gain a new foothold on the moon."
As a result, NASA's Constellation program was born. Never heard of it? That's because it was canceled a few years later. It aimed to send a crewed mission to the moon in 2020 and land the first humans on Mars by the 2030s. By the time Obama was sworn in, the Constellation program was behind schedule and over budget. 1 year later, Obama canceled 100% of the program's funding.
All that has to change. And with the strategy I'm outlining today, it will.
Obama shifted NASA's focus from sending people to the moon and Mars to ultimately just Mars. In the process, Obama asked Congress to increase NASA's budget by $6 billion over the next 5 years. As a result, NASA launched its Journey to Mars initiative in 2010, with the goal to send humans into orbit around Mars by the early 2030s. And until recently, NASA, for the most part, was on track. But then, this happened.
President Trump has relaunched the National Space Council, and at the Council's inaugural meeting in October, we unanimously approved a recommendation to instruct NASA to return American astronauts to the moon, and from there to lay a foundation for a mission to Mars.
Oddly enough, the space policy under Trump and Obama looked nearly identical, except for 63 words. In those 63 words, Trump's administration has shifted the focus once again to a Moon First, Mars Later initiative. NASA isn't new to this. It's learned to recycle old projects to fit new missions. For instance, the Orion capsule was first developed for Constellation and has since been redesigned for a journey to Mars. But even that can't prevent the unavoidable changes NASA programs now face under the new president.
As such, we're also going to realign the organizational structure to best meet this new exploration focus. I've asked Steve Jerzik, the current head of Space Technology Mission Director, to lead an effort to design a new organizational approach.
As NASA pushes on, a new possibility has grown on the horizon. Privately owned space companies like SpaceX have also set their sights on the red planet.
The scientists and engineers at NASA are amazing and they've done extraordinary things, but there's still a risk aversion. That doesn't allow us to do things that are new and novel and on the edge. It's these entrepreneurs willing to take risks and put everything on the line.
The race for Mars is on. While NASA has closely partnered with SpaceX and other privately owned space companies in recent years, ultimately, it might not be NASA who writes the next chapter in human space exploration.
Okay, very exciting. So, I don't know what y'all think about traveling to Mars. I was hoping that video would tell us how long it takes to get to Mars. I've heard varying things. I've heard 9 months. I've heard years, so I don't know how long it takes us to get there. And then there have been certain movies that have come out that are science fiction about people going to Mars, and things like that. So, fun to think about. Now brings us to Earth. Okay, our special planet is perfectly suited for human life. Talk about Goldilocks right here, y'all. It's just right. Designed for us, right? So here's our stats. It's known as home sweet home. We know it's a 24-hour day and a 365.5 day year. Okay. We're the third planet from the sun, the only planet in which man survives in a natural state that we know of. And it's the only place we have found in our universe, the studies we've done, where we find liquid water. Okay, the only place. And that kind of is our definition for if life is possible. Is there liquid water? Gravity holds our atmosphere in place, and we do have a natural satellite known as the moon. All right, so the Earth, of course, has a moon. It's our satellite. And we're going to be looking for our lab today as far as how the moon goes through monthly phases. Okay, so you've probably studied this before, looking at the moon going through from new to waxing, first quarter, waxing, full moon, and then it starts to waning, and third quarter, and waning crescent, and back to new moon. And it takes approximately a month, about 28 days, for this to be accomplished. Okay, so typically we'll have one full moon per month, but because of that 28 days, there is a possibility to have 2 full moons in a month, right? So if we have it like the first and the last day of the month, and what's that called? Is that called the blue moon? The blue moon when you have 2 in the month like that? But it goes through these phases, and it seems to change from our perspective. When we're looking at it, it looks like it's changing. But really what it's doing is just reflecting the light from the sun, and that as it's going around, we're going to see more of it or less of it. Okay, so the phases have this monthly cycle, and we can see we start with no moon. We don't have any moon in the sky at all, right? So it's those are the darkest nights. Best time to view stars, by the way. Then it starts to wax. We call waxing crescent, this crescent shape. First quarter, right here. And then we call it waxing gibbous. Okay, so it's mostly full, but then when it gets to full, it's nice and round, and we can see the man and the moon right there. Then it starts to waning gibbous, last quarter, waning crescent, and new moon again. Okay, so that is the order of the phases. It's really good during this unit to go take a look each evening and see where the moon is and try to guess, is it waxing, is it waning? A lot of times if you have a calendar, it'll actually show you when the full moon is due, and so you know when to go take a look at it. If you have a telescope, it's really awesome to look at the moon with a telescope. It's beautiful. None of our telescopes that we would own in our homes there would be strong enough to see too much, except you can see, even in binoculars, you can see some pretty good craters and stuff on the moon. All right, this is just a little animation showing you. So we're going to have them full, and now it's going to start waning. All right. And there it goes. There's our crescent. And there it goes. I think it's going to start over here. Yeah, pretty cool. So you can see those. It's kind of interesting how the moon is really kind of facing us. One side of the moon faces us all the time. So we never saw the dark side of the moon, the back side of the moon, until the Russians took that photo of it back in the space race times. All right, sometimes the Earth comes between the sun and the moon, and it'll cast a shadow over the surface of the moon. That's called a lunar eclipse. It has to happen during the full moon. Okay, so that's the only time a lunar eclipse will take place. And you'll end up with something like this. Okay, so the Earth is between. Here's our full moon. Remember, it's full because it's reflecting the fullness of the sun. So that's why it's on this side over here. But we'll get in between sometimes, and it'll cast this thing called the penumbra. The penumbra and the umbra. See how it's kind of shady right here? Yeah, and it covers that up. And you're going to see it's going to look something like this. Okay, so it's full, and it starts to get eaten up, right, by the shadow. And then it gets to, I guess it's here next. And we get to this. This is kind of the full eclipse right here. We still see a little bit of that shine. So some people will call that the blood moon. This does take time, probably. It probably takes an hour or so to go through this whole phase right here. But it is, reasonably quick. But that's because the Earth is casting such a large shadow over that, And of course the Earth is moving, so it'll move out and not be casting that shadow anymore. The solar eclipse, on the other hand, though, is very quick. Sometimes the moon comes between the Earth and the sun. The moon appears to cover up or eclipse the sun, and this has to happen during a new moon phase, okay? That's because of its location. So here's another picture showing that. So here's the new moon. So from the Earth, we don't see the moon, right? That's the dark side right there. Excuse me, that's the dark side, but we see this side. Okay, so and we're going to see, look at the penumbra that's cast, though, by the moon. Much smaller than that shadow that was cast by the Earth on the moon. Okay, so the moon casting a shadow on the Earth is a little pinpoint right there, okay? And you can see it now, but they're so much more dramatic. It's happening, if it happens in the daytime, we're standing out there, if we're in a place where it's happening. What was it? Was it last summer that we had it? We had an almost full eclipse seen here. It was either last summer or the summer before, probably then. Okay, and what'll happen is the moon's much smaller than the sun, but it's so much closer that it kind of covers up the whole thing. Now this right here, take a look. Astronomers love when this happens because this allows them to kind of get a better idea of what's happening on the sun. So boy, did they take pictures and they try to analyze this. We can see the rays of the sun coming out. Remember, that's called the corona, which means crown. And you can see here how it looks like a crown. Very, very cool. This takes a few minutes to take place. Now, keep in mind, you know this already. I don't need to tell you, but never look at the sun. Even in a solar eclipse, you've got to have the proper tools for that. All right, and now it looks like we're going to just have our lab left here. The review here, the naming the planets in order: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, Pluto. And we would have done this activity, you've probably done it with me before. This is the one I use for the younger kids, where we take the Oreo cookie and make the moon phases. If you want to tell your folks that, Mom, for science this week, I need some Oreos. And you can do this, it's pretty fun. She'll probably get them for you. So we start with our full moon, and you take a plastic spoon or something, and then take some of that away, eat it, and you get your waning gibbous, and then your waning half, which is our first quarter, and our waning crescent, and then our new moon, okay? And that's when you eat the cookie right there, okay? But then somebody went and did the rest of it, the waxing crescent, waxing half. You can probably just turn these over, right? And then our waxing gibbous and back to full, okay? Here's somebody, I like this the way this person did theirs because they have the sun over here. Furthermore, they also needed more cookies, right? Yeah, to do this. Okay, so it's going to be new. And over here it's full. Let's start with full, I guess. Full, it's going to be waning. Third quarter waning, and then new, and then waxing this way. So pretty fun. And I like to have their Earth in there and their sun over there. It really shows it. Now, but for this class, what I usually do is I get a cookie like this. So I get a chocolate cookie. It's chocolate chip. And I bring some white icing And what you do is you take your spoon and you spread your white icing in the crescent. And then we spread it in our quarter like that. And then we cover it completely. It's a full moon. And then we eat it. Yeah. So I'm sorry we're not together to do that. Okay. That's a bummer. That would have been our lab today. Plus, we needed time to save for... Oh, we're going to do this too. This is your penny thing. So we're talking about how a penny eclipses... Excuse me, how the moon eclipses the sun, but it's not nearly as big as the sun. Watch this little activity. You can do this at your house with your mom or dad or brother or sister or something.
His face. And I'm going to walk toward him. Yeah, you do this. And I get up. This is just a picture, obviously, but I get up there and look. That penny is not as big as his face. Yeah. Okay, so y'all try that, okay? I also do it with a thumb. Do it with a thumb. Okay. And there's my little granddaughter. Yeah. All right. Y'all try that at home.
Okay, so I think the video kind of didn't start right. I was saying how I was holding my penny up at this stage right here, and against the picture, the penny covered up my son's face. But as I got closer, the penny was not. That's exactly what's going on with the moon and the sun. Okay, so you can try that. All right, but last week, I totally forgot to put in the next step of our rocket, y'all, our rocket building. And so this week, here it is. So you're going to do this step right here. Where you're gonna take this and use your glue. Now, did we put that on last time? I think we did that last time. So right here, we're gonna put the line on our tube right here. So you hold it against the door. This is brilliant, really. To hold it against the door, you'll have a nice straight line. It's important for that line to be straight because that's gonna be where our little launch tube is. It's like a little straw you're gonna glue on there, and it needs to make sure that our rocket will go up straight. Okay, all right. And then this was our this week's deal right here. All right, we're going to install the engine mount. Okay, so you're going to take that part that was put together, and if it was done a week ago or so, or two even, the glue should be nice and dry and all that. So you're going to put that into that tail fin area, and then you're going to put this other piece right on top of that and glue it on so that it's going to stick. Let that dry, and then the whole thing is going to be attached to the body tube. Okay, so you're going to put that up in there with some glue, and then you're going to let it dry. Notice here that that line that you drew needs to be between the fins right there. Okay, make sure it's between the fins. Otherwise, when we try to launch it, you're not going to be able to get it onto the launch rod very effectively. Okay, it's not going to work very well. All right, so that should take you a little bit of time to get that done, and so maybe some of you have already finished your rocket. Maybe some of you haven't even started. But try to get, if we were together, I would have you doing these steps as we go each week. All right, so that's it for our lecture today, and hope y'all have fun with that. Okay, see you soon, I hope.